Hello and welcome back to the Python programming series for kids and beginners. In this video, we shall discuss an important topic which is reusability of code. And we shall achieve this reusability by leveraging functions and libraries. Let's get started. I'm sure you must have used a Google Assistant by saying Hey Google, or use a Siri on your Apple phones by saying Hey Siri and asking them for various things. As an example, Hey Siri, what is the temperature today? So Siri is able to perform some functions for you and is able to get you the temperature for your city today. Similarly, you may have gone to a cafeteria and should have ordered something. Let's say, can I have a coffee, please? So, coffee is being served and it is abstracted from you how exactly the coffee is getting prepared. You are just responsible for calling and receiving the output. So, you call with some input. In this case of cafeteria, the input is the money and what exactly you need, that is another input, and the output which you receive is your order which you have ordered. So that's what the functions they do for us. They provide you a mechanism where the functionality is hidden from you. It's the output which you care about. You don't care about how that output is achieved. Functions are very important because they grant you reusability. If I have done a function, I can share with hundreds of people if it is really that useful, and those people can use it, and they are not bothered about how exactly it's written, what are the contents inside the function, what algorithm it leverages. They are only bothered about what is the input they provide, what is the functionality, and what exactly is the output they receive. Now the functions can be of two types. One is self-defined functions. So you define your function in your program and you use this function at multiple places. So you don't have to repeat the functionality at multiple places. Also, you are able to neatly organize your code. And if in case there is a change, you have to make the change at only one place where the function is written. And the second way is you can also leverage functions which are written by somebody else by importing the libraries where those functions are available. We'll see both the approaches. So now I have opened the Colab and I would be putting a text section here explaining what I'm going to do. Let's say defining, I'm adding multiple code blocks so that they can be used later on. So defining and calling functions. So let's say I want to create a simple function called greet name and print. Again, like I said, indentation is very important and the colon is very important. So I had missed the colon, so default indentation did not come. Now the indentation comes by default here, and I say print, formatted print, and I say hello. So now what is happening here is that you have written a function. The name of the function is greet and it accepts one input parameter. The name of that input parameter is a name, and it leverages that input parameter to do something, which is just print that name. So if I say greet John, it will print this. And now once I have defined it, I can call it multiple times and I can say Mary, and there could be a different functionality here, which could be, let's say I want to count how many people I greeted today. Greeted number of people. So now what I have to do is I have to write this specific keyword which says, and I would explain you what exactly is the meaning of this, but I would have to say global greeted number of people. So now what it says is that today I greeted two people because this is getting called twice. Okay. If I say one more greeting, let's say I greeted three people. So what is happening here is that I have created a function which accepts a parameter called name, and I say that I want to leverage the variable which is defined outside the scope of this function. Why I want to use this outside the scope of this function variable is because there is the variables which are defined inside the function are not accessible outside the function. So if I define a variable, let's say a local variable equal to 5, I can't access the local variable outside. If I say print it shall give me an error because this local variable is not defined in the scope of in global scope. So it is defined locally to the function and it is available inside the function only. You can leverage this here. You can say print local variable, but you can't say print local variable outside the function scope. Okay, so this you can print, but this you cannot do. And if in case you want to use something which is defined outside the scope of the function, then you have to say global. This means that I want to leverage the global variable which is available across the program. So I'm defining a function which returns a value now. So in this case, what is happening here is it is returning me a value, and that's what I'm printing. So this is how you can have return from a function. You can use something as a default parameter, which shall be leveraged if in case you have not provided the parameter. So these are called input parameters like we discussed earlier. If I want to provide a default value, I can say y equal to 4. So now what will happen is if in case I don't provide the value of y and I run this, it prints 7 because 4 it takes by default. But if in case I say, let's say 8, then it should give me 11 because the y is given as an input parameter and thereby the default is overridden and the input which is provided is used instead of the default value which I had provided here. So let's say that there are some functions which are provided by some third party vendor and you want to leverage them. Now there are a lot of libraries which are available for Python and you can import those libraries in your code and you can use those libraries. What kind of libraries are there? There are standard libraries which comes packaged with the Python itself and you need not install them. And there are third party libraries which are required to be installed in your system before you can use them. So let's see both of them. So these are some standard libraries which are available with the Python installation. What exactly they do, it's not important. As and when you will be using them, you can understand what they do. But these are the libraries, some of them we are going to see in this course. These are the third party libraries which are available, which means if they are third party, they don't come pre-installed with Python. So thereby you have to say pip install whatever is the library name. In this case, the library name is request, and in this case, it is numpy. So whatever library you have to install, you have to say pip install followed by the library name. Once you have the library installed, or you are using a standard library which does not need installation, if you have to use the library, you have to import it. And how you can import? You have to just say import and then the library name, and then you would be able to use the functions which are available in the library. For example, square root. This comes in the library called math. So you would say math.square root of 25 and you will get 5 as a result. If you want to import only specific items, not the entire library, you can import specific modules. So for example, I'm saying import only sqrt and sign from the math library. So then these are imported and then I can say square root of 16 and sine of 0 is how much, and I get the relevant output. There is another thing which is alias. So we use alias when we want to replace the name of the library by something else. Why do we want to do it? We want to do it to write in a short way or to conform to some standards which are there. For example, people use PD for pandas if they import pandas, or they use NP for NumPy if they are using NumPy. So these are some of the standards. So to conform to the standard, what you say is import pandas as PD, or you say import NumPy as NP. And then whenever you have to use that specific library, you have to say NP dot in case of NumPy. Here we are importing math library as M, and then we should be able to call the functions by using M dot. Okay, so which means math dot square root of 9. So let's import some of the standard libraries here. Okay, and we get the square root by using the math library. We could have written our own square root function, but it would have been so cumbersome to write it and not at all needed when there is a library which is provided to you, which you can quickly use for your maths. And the other thing which we were saying was the alias. So let's see that also in action. I copy the same code and instead of this I say as M. Okay, and then I can say m.sqrt, and I can call it anything. I'm calling it I can call it John Doe. It is any name of my preference, and then I would be using that name to call that specific functionality. Now we've been using this a lot of functions, and there are a lot of functions which we have not covered. And when we are using these functions, many a times we would like to get help on how to use them, and that's where these command help. Okay, so we have a dir command. I'll show you in action how exactly what exactly it shows you. There's a help function which is there. There's a doc attribute which gives you some details on the specific function or object. And there in the Jupyter notebook or in the Colab, there is a question mark also, using which you would be able to get help on that specific functionality. Let's see all of these in action now. Let's say I create a x equal to 5. So I created a variable by the name x, which is an integer. Now if I say dir x, I would be able to see what all functionality I can call on the integer. Okay, so these are the different things which can be called. So it would tell me that I am able to use cosine, degrees, dist, e, ceiling, all these functionalities from the math library I'm able to use. A function called help on the math, and then I would be getting a detailed description of what all functions are there and what they do. So this help is very, very helpful. And we were also saying that in case of Colab, you can do this also, a question mark, and you would be seeing the help. So you would be seeing the help here. It says that it returns the square root of x. Okay, you can do it for sin, and it gets you the sine value of x. So what are the exercises which we have to do in this specific chapter? We have to do these 5 exercises. Uh, Again, they are very simple exercises. Input number is even or odd, calculate the factorial, make a simple calculator, check if a number is a prime or not, and write the Fibonacci series. So let's do this one now, because there is an important concept which comes in place when we discuss the factorial. I would write a function called factorial. So this is a concept which I wanted to describe here. In the function, I'm calling the same function again. So this factorial function is there. Inside the factorial function, I'm calling this function again. So this is called recursion, where a function calls itself in order to solve a problem. So this function, for example, it will first call for the 5. So when it calls for the 5, it will go here, it will say 5 into factorial of 4, because now 5 was the input, 5 minus 1 is 4. Again, it will go here, it will say 4 into factorial of 3, because 4 minus 1. Then for 3 it will say 3 into factorial of 2, and then it will say 2 into factorial of 1. So when you get 1, it will say return 1. So which means it will no longer call this part, else part, it will go in the if part, and thereby you would be able to get the factorial calculated. This is a very, very powerful concept called recursion, and you should create this program on your own to understand what is recursion in programming. So with this, I'll close. Please go through the exercises and complete them. Thank you very much.